Hello, and thank you for joining us for the webinar, The Value of FDM Jigs and Fixtures, Who, What, Where, When, and Why. My name is Kim Kaloran, and I'll be your host for today's event. Before we get into the meat of the event, I wanted to give you a brief overview of Stratasys. For those of you who aren't familiar with our company, Stratasys manufactures 3D printing equipment and materials that create physical objects directly from digital data. Its systems range from affordable desktop 3D printers to more larger and advanced production systems, and we are passionate believers in the value and power of 3D printing and the change it can bring to the world. Also, a little bit about the technology. All Stratasys 3D printers build parts layer by layer. PolyJet technology, which you see on the left, employs an inkjet-style method to building parts from liquid photopolymers in fine droplets, which are then immediately cured with UV light. FDM technology, fused deposition modeling, extrudes fine lines of molten thermoplastic which solidify as they are deposited. The Stratasys portfolio of 3D printing materials is the most comprehensive in the industry, including over 500 PolyJet photopolymers and FDM thermoplastics. And before I introduce Rob, I wanted to make another quick note. At the end of the webinar, you'll get a link to a place where you can access these slides as well as the recording and other information on this topic. So now to get on with it, I'd like to welcome our main presenter today, Rob Winker. Rob is a corporate FDM applications manager at Stratasys. He has 8 years experience in the additive manufacturing industry and gained a bachelor's degree in industrial engineering. Rob, it is all yours.
All right, thanks, Kim, and thanks to the rest of you for joining us today. Basically, what I want to do is start off with an overview of where Jigs and Fixtures fits into the additive manufacturing landscape. And that landscape starts with the basic concept model. So concept models are used in additive manufacturing for the design cycle, and it's basically the fit and form products that you're producing to check those fit and forms. Then you move on to functional prototypes, which you can functionally test before you go into production. And so those two things combined make up the design cycle, and additive manufacturing is used for that. Then you move into manufacturing tools, and that's where jigs, fixtures, and other tools such as patterns are used in manufacturing. And in the last probably 5 to 10 years, this is really where additive manufacturing has gone from the design cycle and moving into the manufacturing world with the advancements of additive manufacturing technologies such as the FDM technology that we're going to be covering today. And finally, in manufacturing, there's the direct production of end-use parts, and we're seeing more of that in the last few years. And I think we're going to start to see a lot more of that in the near future. So manufacturing tools and end-use parts make up that manufacturing scheme where additive manufacturing is used. So let's jump into manufacturing tools and specifically jigs and fixtures being built from the FDM technology. So the reason why we're talking about jigs and fixtures with FDM and why it's beneficial to our customers is because most customers that have a system, jigs and fixtures is applicable to them in some sort of way. So from our research, more than 80% of FDM users use their system for some sort of jig and fixture production. The reason why is that it saves a lot of money versus their traditional manufacturing process and gives them a good ROI and utilization of their system in-house. Another value that it gives to that end user is that it can be divvy that system up from just the design department using jigs and fixtures to various departments throughout the organization taking advantage of this technology that they have. So let's take a look at a video showing the overview of FDM jigs and fixtures.
Manufacturing relies on jigs and fixtures to maintain high levels of quality and production efficiency. Time is money, and money is money too. With FDM jigs and fixtures, you can save both. FDM works great for complex and organic designs, and it can perform as well or better than your traditional jigs and fixtures.
Here at Org Manufacturing, we're able to use FDM and rapid prototyping to create jigs and fixtures because it's faster than doing things like CNC machining, and it's lighter and it's cheaper than any other process that we've used.
FDM jigs and fixtures can reduce lead times up to 90% and provide cost reductions of up to 95%. Streamline your process, save time, save money. Try FDM jigs and fixtures at your facility. Visit Stratasys.com to find your local reseller and find out how much you can save.
Okay, so I've laid out the agenda for today's presentation in a way that walks through the process of how jigs and fixtures are traditionally processed and fabricated to the way that you can fabricate jigs and fixtures with FDM. And along the way, we'll kind of highlight who, what, where, when, and why you use FDM jigs and fixtures. So the first thing that we need to know is, obviously, what is a jig and what is a fixture? So a jig controls the motion or location of a tool. And a fixture is the device that holds that work in a fixed location. So the reason that manufacturing industries rely on jigs and fixtures is because they maximize production quality and they increase production efficiency. Basically, what I want to say here is jigs and fixtures in manufacturing are basically invisible. Nobody knows about them. Nobody really talks about them until there's a problem on the production floor or something like that, or there's a lot of scrap or some problems going on, and that's when it becomes evident that there's an issue, and a lot of times the solution to those problems are implementation of a jig or a fixture. Basically, they're used to position, hold, protect, and organize various either tools or pieces of work in a production environment. So let's look at where jigs and fixtures are used. And there's a pretty obvious one, I think, that comes to the top of everyone's mind when they think of a jig and fixture, and that's the manufacturing line or the assembly line. And very true, that's the most obvious place for assembly aids, holding fixtures, and nesting fixtures. But if you look at a more broad look at these industries, they also use them in their inspection lab. So CMM, part fixtures, check gauges, things like that. During the during the engineering process, R&D engineering, they use a lot of test fixtures to validate designs before they move into production. And transportation and inventory is another one where they have part carriers and holders, assembly line pallets, protection devices, as well as 5S organizers for organizing tools. I think a good example of that is a story that we have where on the International Space Station there is a FDM Ultem material toolbox floating around in the space station that holds the astronaut's tool. It's a good example of inventory part holders. And finally, one that's kind of a niche industry that uses their own special kind of jigs and fixtures is the medical industry, where they use a lot of drill and saw guides in operations and surgical procedures. So the next slide is where are you gonna find these jigs and fixtures, and who is going to be using them. And essentially it's any manufacturer looking to position, place, hold, or organize. And when are they going to implement a new jig or fixture? Really, you want to look at if you're starting a new project, there's going to be a need for jigs and fixtures for a new project. If you're opening a new facility, or if you're starting up or expanding a new production line. All good cases where an influx of jigs and fixtures are required. I guess where jigs and fixtures with low cost and the ease to build complex fixtures, which is where FDM really fits, is going to be places where it might take too much time to build them traditionally, or it might be too expensive to make a traditional fixture, where there's a bottleneck in the fixture making production process, where it's going to take too long to get the jig and fixture so you're delaying production. And in situations where it's nice to have a jig and fixture, but it's not required. So maybe the cost of making one traditionally might take too much time, might take too much money, so you know you can do it without. So you take the risk of having scrap or having problems with the manufacturing process by not implementing a jig and fixture. And the other key thing for who's using jigs and fixtures are industries and people that are, the creative, innovative people who can take the time to get away from the status quo, the norm, and really look at a new way of manufacturing these devices. So let's take a look at some of the companies that we know are using FDM jigs and fixtures today. And if you look at this list, it's pretty obvious that we have some really big name companies on there. BMW and Honda from the automotive segment. BMW is a really good case study for Stratasys jigs and fixtures. They have hundreds of inspection fixtures on their manufacturing floor, such as go, no-go gauges and other things. Lockheed Martin in the aerospace industry, and typically when you think aerospace, you think very large jigs and fixtures, and yes, they are doing large jigs and fixtures, but they also have jigs and fixtures that can be easily built in a single day to help with those simpler, smaller operations. So a wide variety of companies benefiting from this. Well, let's look at where FDM fits. So to do that, you have to look at what are you doing traditionally to build these jigs and fixtures, and typically it's CNC machining with combination of manual fabrication out of wood, plastic, or metal. And you would do this one of two ways, outsourcing or in-house. And if you were to outsource, it's going to take you on average for, in this example, a 5 cubic inch part, between 5 and 20 days to outsource it. And that's shipping time, lead time with the vendor. And it's going to cost, depending on the complexity of that small fixture, let's say it's a nesting fixture, between $100 or $2,500. If you were to bring that in-house, the traditional fabrication of these fixtures in-house, you reduce the time to about 3 to 10 days. And that really includes setup for the machine operator doing the procedure, creating the 2D detail drawing that the operator needs to fabricate your device, and going through the internal logistics of making this process happen. So some time savings there and some cost savings as well, so between $50 and $1,000. And that includes raw material cost as well as the operator's time to set up and run the equipment. Now, if you look at FDM's role, this is basically to directly replace the production with the FDM system. So you can do this in-house, and typically it's less than $100. The reason we can do it for so cheap is because there's no, I guess the FDM technology is basically a lights-out operation. It runs by itself. It's quick and easy to process and the files to get them to build on the machine. And then, so basically most of that cost is raw material cost. Operation time is you can build a simple fixture between a half day and a day. And what that means is if you determine that you need a fixture for your plant or for one of your departments, you can design it and then send it to the machine, and the next morning when you arrive, it'll be at the machine completed, ready to put on the manufacturing floor. So let's look at where FDM is a best fit. Where would you actually implement FDM fixtures? So typically this is a low volume application, 1 to 100 parts. And good news about jigs and fixtures, usually you don't have mass production of jigs and fixtures. It's 1 per line or 1 per cell or 1 per operation. The best fit for size is something less than 12 cubic inches. And the reason for that is it eliminates the need for fabricating multiple parts together or bonding. and that fits in the FDM systems quite well. Now, you can do larger parts if you have a larger system, and you can even bond parts together to do very large parts depending on your needs. So it is quite common in the aerospace industry to do parts much, much larger than this. But the best fit, and there's a large variety of jigs and fixtures that fit within that window of 12 cubic inches or smaller. Some key considerations to think about is that thermoplastics have to be acceptable. That's what the FDM technology builds from, is real thermoplastics, and it's a range from simple ABS to high requirement polyphenol sulfones and thermoplastics like that. The other one is the accuracy of our machine. So the fixture has to be greater than or equal to plus or minus 0.005 of an inch accuracy requirement. That's the best fit. You can get better than that with some secondary procedures or some validation tests, but for an everyday fixture, you really want to start out with something that fits in that range. And then the temperature and chemical resistance have to match that of the material that you're building from. So FDM, again, is the best fit when you're replacing or as an alternative to manufacturing a complex part. And then when you're doing complex parts, there's no added cost, not much added cost or time to a build related to the complexity of the part. So if you design a complex part or a simple part, both of those will cost essentially a similar amount of money in material and take a similar amount of time to build on the system. So let's look at the benefits of using FDM. And the pretty obvious ones are the time and cost savings. So you're looking at 40 to 90% lead time savings over traditional manufacturing methods. And you can kind of get into that if you look at the image on the right. The upper right corner there is a 2D detail drawing of a very simple U-shaped alignment fixture or assembly fixture that assembles this steel assembly together to spec. And essentially, if you take the 2D detail drawing, you have to create that. You have to design it to match your the traditional manufacturing methods, which is probably CNC machining combined with fabricating multiple components together. And when you use FDM, all you do is design the 3D CAD part, build it on the machine as a single part, eliminating the fabrication and eliminating any design constraints from the fabrication method, since additive manufacturing virtually has no design constraints. Basically, what I like to say on a benefit like this is that it takes what would be a project from creating the 2D detail drawing, creating, working with the outside vendor, purchasing, or your inside machine shop. It eliminates all that and turns it into a simple task of simply design your 3D file, send it to the machine, and have it building. And the last one that we have here is the digital inventory, which is really beneficial if you need to duplicate a file that you already have. There's no need to have another send it back to a machine shop or have more user interaction. You already have the files processed, just simply duplicate them for replacements or iterations to the version. So the next thing that you want to do is design for function. So if you look at the picture on the upper right, it was designed for traditional manufacturing, which means multiple components assembled together. With FDM, you can integrate multiple components into a single component, and then you can also add things such as RFID tags can be embedded into the part. Text could be put on the surface of the part, such as part numbers, instructions, and guide arrows or something like that. And another thing is designed for FDM. So if you look at the picture in the upper right, it's kind of the way you would imagine if you're CNC machining this out of a block of aluminum. Well, you're not doing that with additive manufacturing. So in the picture in the middle, you can see a design that was created for its raw purpose, which saves a lot of material, saves build time, and a part like that you can build in about an hour or two, compared to wasting a lot of time building up material. Another advantage of the FDM additive technology is the ability to put ergonomics in mate complex structures. So in the bottom right, there's a label alignment fixture for a car that puts the badge on the back of a BMW in this case. What they've done is they've ergonomically designed that handle so that it's easy for the operator to control and hold. They also use a lightweight structure, a sparse fill interior, which reduces the weight and eliminates operator fatigue, which lowers cycle times and makes it easy to use and easy to store. So that's kind of my overview of how customers are using FDM and the benefits that they're getting. Let's take a look at Auric Manufacturing, a vacuum cleaner manufacturer, and see what benefits they're getting from FDM. So a little bit of the backstory of Auric Manufacturing. When they come up with a new product and they work on vacuums, they get about 20 to 30 products, if it's a die-cast component or a injection molded component, from their supplier back to their manufacturing facility in a batch of the 20 to 30 components all at once. So what they need to do is do first article inspection on all those components and make sure that they're acceptable for manufacturing and assembly. So in their CMM inspection metrology lab, they utilize FDM technology to build a prototype of the production part. What this does is it allows them to pre-program their CMM. Well, you can't pre-program a CMM if you don't know exactly where the part is going to be located on the CMM table. So they also build a jig and fixture, a fixture to hold, it's a nesting fixture to hold that component into a fixed location on their CMM equipment. So with those two parts, they mount the holding fixture and they pre-program their CMM. They do this for the 20 or 30 parts that are expected to be coming in from manufacturing, and they'll then wait for the production parts to arrive. Once the production parts arrive, they can test those parts in a matter of 1 to 2 days, because the fixtures are made, the programs are made, and they're simply running through the program that's been pre-processed. So that if you look at their total inspection time with traditional CNC aluminum fixtures, or with the traditional setup posts on the CMM, it would take about 30 days to do the setup at time of part arrival, where with FDM, where it's pre-programmed, it takes them about 1 to 2 days. If they were to CNC aluminum, out of aluminum, the fixtures that they need, it takes about 7 hours for them to do this in-house at a cost about $250. That's material cost and machinist time. With FDM, it takes about 3.5 hours to produce these nesting fixtures, and about $55. That's the CAD designer's time, as well as the material cost, which both come out with a pretty substantial savings for Auric, both in time and cost. So now we'll take a video and hear Auric tell how it's saving them money.
Auric manufactures the best vacuum cleaners in the world. We're the only manufacturer of vacuum cleaners in the United States, and we make the lightest weight, most powerful, simplest vacuum cleaners available. Stratasys systems here at Auric have helped improve our new product development and even some of our sustaining product capabilities.
One of the things we can do here is we do not have to do drafting and some of the radiuses and things, the sharp corners that we might do in a new design. So we're able to create new parts very quickly and can test those parts from a design side.
I use FDM here to build fixtures to measure our parts for our uprights and floor care products on the coordinate measuring machine. With traditional measuring methods, a lot of times we couldn't do any programming for the CMM to do first article inspection until the parts are actually made in the new mold. That could bleed up to well over a month of bottleneck. Everybody's waiting on first article inspections. Now with FDM, we can make the fixtures, we can make prototypes of the actual parts before the molds are even made. And then when the parts come in the door from the actual mold, I'm ready to go. All I gotta do is bolt the fixture on, put the part on, press the go button on the CMM, and I can knock all the parts down to maybe 2 days.
Beyond new product development, we also use rapid prototyping to be able to help place our products for assembly on carts, things like that. It provides the capability for our assemblers not to have 5 hands to be able to put parts together.
Using the Stratus system helps us in a lot of ways. A lot of these nests have some complex shapes to them, and typically if you were to ask a machinist to machine one of these out, he could easily spend a day on each one of these nests, where with the Stratus system we can turn out multiple of these in the course of the day.
If you're considering using the Fortis for manufacturing, I would highly recommend it because it's beneficial in a high-paced, fast-moving environment.
FDM uses go well beyond the new product development stage. Assembly, manufacturing, quality control, that type of stuff is better, cheaper, and easier to manufacture, quicker than any other process that we've used.
Okay, so that's pretty interesting how Oric uses jigs and fixtures in the metrology lab. But now let's look at the broader scope of jigs and fixtures and really how they're used, not just in one specific case, but as we said, throughout various departments, from the manufacturing floor, where they're using assembly aids, nesting fixtures, custom equipment guards, to the metrology lab like Oric Manufacturing is using, but for life cycle testing, mechanical testing, go, no-go gauges, in through transportation and inventory for 5S tool organizers, part protectors, part carriers, end-of-arm robot tools. The medical industry uses it, like I said, for drill and cutting guides, and engineering and R&D using it for test fixtures. Let's see how they're really using these parts.
Wherever there is a need to hold, position, place, or organize, you will find jigs and fixtures. They are used by nearly all industries: aerospace, automotive, consumer products, medical devices, and healthcare, just to name a few. Within a company, you will find them in research and development, manufacturing and assembly, inventory control, quality control, and transportation. We'll walk you through a few of those departments. Tools that once were traditionally fabricated out of wood, plastic, and metal, either with hand tools or machine tools, are being made with FDM. By simply substituting FDM for traditional processes, companies are producing jigs and fixtures faster and at a lower cost, and they're making far more of them because of the ease and efficiency. Before launching a new product, extensive research, development, and testing are performed, and FDM jigs and fixtures are there to help. From fluid line mounting fixtures to gauge mounting fixtures, check gauges, and fan testing rigs. Need to test a light bulb or specialized hardware? FDM can make a fixture for that too. The durable FDM plastics are perfect for your life cycle testing. Fans, keypads, vacuum cleaners, and many other products. When testing reveals a need for a change, simply 3D print another FDM jig or fixture for the next go-around. On the production floor, FDM jigs and fixtures make work easier and safer, and companies that use FDM find that they have more of them than ever, since they are so easy and inexpensive to make. Make a masking tool for conformal coating electronics and cut out manually taping each printed circuit board. Or build a dispenser for factory floor labels. For assembly operations, use FDM for nesting assembly fixtures, rivet guides, or assembly guides. Need a one-of-a-kind tool? You can easily produce that too. According to 5S principles, a neat and orderly work area increases efficiency. Make custom tool holders so that everything has a place. And to move product around the shop, FDM is a great option for transportation racks, bins, and fixtures. Have a robot? You could machine the end-of-arm tooling, but a better option is to make them with FDM. And for a safe workplace, use FDM to make customized guards for all your manufacturing processes. Look around any shop and you will see countless opportunities to improve operations with FDM jigs and fixtures. Quality assurance requires accurate, repeatable holding and positioning to validate products, and once again, they turn to FDM. For coordinate measuring machines, CMMs, FDM fixtures place parts for programming and final part inspections. Without FDM, the inspection lab may resort to painstakingly setting up a fixture each time a part is measured. But once they have an FDM system, they can produce custom fixtures for any shape, even those difficult to hold. Before production parts arrive on the dock, CMMs are programmed using FDM parts and fixtures, so that when production parts do arrive, CMM inspection is completed very quickly. And 5S isn't just for the production floor. In the lab, use FDM organizers for all the measurement tools and gauges. From R&D through inspection, FDM is the tool to make work more efficient with jigs and fixtures. For further information, contact Stratasys Application Support.
Well, there it is. We've seen jigs and fixtures throughout a variety of industries. We've talked about why they're beneficial to a company, where they save you time, where they save you money, what FDM's role is, which is basically a direct part replacement for traditional fabrication methods, including even where they're used throughout the different industries and different departments within virtually all industries.
Thanks, Rob. Appreciate the presentation. Some good information. So in a minute, we'll take any questions that may have come in from you as the audience. If anyone has a question in the meantime, please submit it through the Q&A or chat panels. After the event today, you'll have access, as I mentioned, to download a copy of these slides and the actual recording of the webinar at the URL on the screen, stratasys.com/webinar-jigs and fixtures. Also at this URL will be links to download some additional documentation around jigs and fixtures. And Stratasys is here to support you in many different ways. So you can connect with your local reseller to request a benchmark to be made to really get the idea of how this may work in your situation if you want to get a jig or fixture made. And there is also a link on this URL to an online form where you can submit more technical questions as well to our application engineering department. All right, now on to the Q&A portion of our webinar today. Looks like a few questions have come through. We'll try to get through most of these before our time runs out. So, Rob, are you ready?
Yep.
All right. Here is one from George, and he's asking, I want to use 3D printed jigs and fixtures in my factory, and where do I get started?
Basically, what I've seen is the best way to get started is maybe take a walk around your facility. Think about what we talked about today and the different departments that are using jigs and fixtures, and have conversations with those people, with the metrology manager, with the manufacturing manager, with the engineering R&D, or if specifically you're in one of those departments and you want to utilize it for your department, talk to your people and see what they're using, where their problems are, where their limitations are, where they're spending too much money for jigs and fixtures, or where they're not using them because of time constraints or cost constraints or something like that. And really, when you actually find a few, there's going to be some ones that might be really complex and a very difficult situation. I would start with the more simple. You know, it'd be nice to have one here. It's a smaller part, but it could help us combine multiple tests into a single test. So maybe various accuracy checks or inspection checks on the manufacturing floor. Those, something with a complex shape, but start simple, something that would fit in a machine or be that smaller size, and then let it snowball from there into the more complex problems that you have at your facility.
Great. Here's another one. Carrie would like to know how much freedom will FDM really give her versus traditional fixtures?
How much freedom will it give you? So I guess using FDM jigs and fixtures, it is a lights-out operation. It saves you time and it saves you money versus, like we said during the presentation, it takes what would typically be a project, so finding a designer to design the fixture, then having them create a 2D detail drawing, have you work either with purchasing to go to an outside vendor or to your machine shop and work through the details of having it produced in-house. It eliminates all that and lets you basically design it yourself and put it onto the machine. So, yeah, I guess that's where I would start with that question.
Okay. Kind of a similar idea, but more in the design area here. Phil is asking, how do I or do I need to optimize my design for FDM?
Yeah, you don't have to, but I think you're going to find the most benefit if you look at your manufacturing process. So the benefit of the FDM and additive technology is that there's virtually no design restraints. So you don't need to design with the standard restraints of starting with a big block of material and machining it down or drilling holes or assembling multiple components into a single component with drilling and tapping and screws and stuff like that. So if you optimize your design for FDM, you can take what would be a traditional design, which might take a long time to build that mass, because traditionally you would build from a block of aluminum or something like that. And you can design from FDM and only have the critical components that you need. You can also integrate the design that you're looking for, so you have the design freedom to come up with exactly what you're the exact use for that fixture.
Okay. Here's another one. Galad is wondering what material is best for jigs and fixtures.
So the FDM jigs and fixtures aren't going to work for everything. It's not a direct replacement for everything on your manufacturing floor or wherever you're using jigs and fixtures. You want to look at the requirements. So the Stratasys FDM machines have a range of materials that they have. They're all thermoplastics, from ABS all the way up to engineering thermoplastics such as PPSF, which is chemical resistant, has great mechanical strength, and can be used for a variety of things. So really you want to ask yourself a couple questions. What's the, is there going to be chemical exposure? What's the load requirements on my fixture? And what are the heat exposures to that fixture? And then if the FDM materials that we have available match those requirements, just choose the appropriate material.
So it really just depends.
It depends.
Yeah, okay.
Well, that's the easy way to say it.
At this point, looks like we have time for one more question before we need to close out the call. Trent wants to know, when should we use plastic versus metal for jigs and fixtures? Is it strong enough? So similar to our last question.
Yeah, not always. So plastic's not always going to be a direct replacement. Sometimes you're going to require the strength of an aluminum or steel fixture. So it really just depends on the loads that you're looking to replace. But I think what's happened is when CNC machining came out and the parts that you get off that, a lot of people use that technology because it's the technology that they have, it's the use that's available, but the requirement for that aluminum or material isn't always required. So you can quite often replace aluminum fixtures with plastic fixtures without fear of failure due to the mechanical strength.
Okay, great. Looks like our time is about up. If we didn't get to your question on the call, we'll be sure to follow up with you afterwards via email. Thanks again to Rob Winker for your time and insight, and thanks to all of you for your attention during the call. Now I will turn it over to our operator who will close out the event. Thanks.